Hello, my name is Craig Clare, and for this semester's project, I decided to do the optimization of a squat rack safety design. So, a brief overview of this piece of equipment. It's used in the fitness world for a variety of exercises, and the great thing about this is that the J-cups, which is the primary barbell holder, are adjustable, and so are the safeties. But back to the J-cups. So, this is where a person places the barbell initially, and after a set is complete of an exercise, it is returned to this location. However, if during a set or a rep of an exercise someone is to fail, the safeties are designed to catch the barbell off their back so they can remove themselves safely from under the weight. However, the issue with the current designs is that they're difficult to adjust and they're rather heavy and bulky. Because of the weight, people sometimes opt just to remove them entirely, just so when they're moving from one workout to the next, they don't have to worry about adjusting the heights of the safeties. However, because of the removal of safeties, there is an injury risk that is associated with squat racks, and as you can see in the bottom right, this is a good example of how safeties could have been used. The safeties could have caught this barbell off this man's back and could have prevented a major injury. However, with major injuries comes surgeries, comes months of rehabs, and also the mental block to do that lift again in which you got hurt in. And so, in the grand scheme of things, this time off from fitness will lead to worse health of these people. So, in my opinion, I think a lighter design for the safeties that could still hold the same amount of weight would be very beneficial. And so to find the solution, I decided to use the software Solid Thinking inspired by Altair HyperWorks. And as it says on the website, it can be used to enhance the concept developmental process by generating optimal structural concepts. So in other words, I'm going to use this to eliminate all the material that is not needed to handle the weight. So the model scenario I'm going to use is I've decided to use steel as a material because it seems pretty standard across the board in the industry. And looking at other competition to my squat rack safety design, I got the following dimensions. So I wanted the design space length to be 24 inches, the height to be 14 inches, and the width to be 2 inches. And that's the maroon area to the right. I also decided to use a box beam to the top because that's also pretty standard in the fitness world. So a common industry test is the bar drop, and that's what I decided to model as the force that it needed to handle. And so a competitor, Rogue Fitness, their safeties can hold up to 800 pounds during this bar drop test. And so a bar drop test is basically a user drops a barbell from their shoulders and sees how much weight the safeties can handle. And so I decided to model the 800 pounds as just an impact force and then take that and model as a torque. And so as you can see, the circular arrows in the models to the right, that is where I applied the torque. And the magnitude of it, after some simple calculations, turned out to be 27.2 kilonewtons per kilonewton meter. And I decided to model this as a cantilever beam because that's a common design, and that is so one of the ends is constrained. After this model was ran in the software, the results were pretty good. To the top right is what the software produces, and as you can see, because of the rough edges and just kind of the difficulty to actually construct that in real world, I also made a design in SolidWorks that would be easily machinable. And so with my SolidWorks model against the competitor that has similar performance results, mine is 24.3% lighter, which I think is significant and could actually be very beneficial in the future. So after this, if this was to actually go in production, this could lead to encourage people to use safeties. It would prevent serious injuries, cut down time during exercises, and result in an overall better workout.